One application I wanted to explore with this Tenma power supply is the whole idea of the impedance in power leads. So this is a USB cable, and I have put a shorting connector on the end of it. So this end is a dead short between the positive and the ground. And if I plug it in to the 5-volt USB power connector on the power supply, if I want to use the USB port, I have to turn on the USB, and it automatically sets the voltage to 5.1 and the current to 2.5. But I want to set the current to 1 amp, so I'm going to take that down and take this one down to 0. So we're at 1 amp. And it's going to stay at 5.1 volts, but because this is shorted, it won't stay there for long. So if I turn on the output, we can see that we have 1 amp, and if I'm displaying voltage, we can see that it's 1.27 volts. So this cable has 1.27 volts drop in it when you're putting an amp through it. So that's not good. It means that you've only got 4.1 volts reaching your device if you're drawing 1 amp. So I'm going to look at how this performs testing cables, and I have a little custom card here with 4 10 ohm resistors on it that can be switched in individually in parallel to create a load with a minimum resistance of 2.5 ohms, which is a couple of amps at 5 volts. I've actually set this up for 3.3 volts, and I could plug this into the 5 volt USB port, but I've made up another little card here which has a USB connector on it, which allows me to connect a USB cable into the main power jacks. So if I turn on the output, it's 3.3 volts, and 0 amps. If I turn on one of these resistors, it goes up to 0.3 amps, and it will go up by 0.3 every time I click in a new resistor. So it's up to 0.6, 0.8, and about 1 amp with all 4 in there. And there is some voltage drop in the cable, and it's contributing to the resistance, so it's not exact, but that's just to show that it's working fine. The power supply is working fine. It's still generating 3.3 volts, and whether these resistors are in or out. So here I've set the voltage at 300 millivolts, which is as low as I can set it. So if I go into setting and try and decrease this, I can't. It's 0.3 volts is the lowest setting, and I've set it at 1 amp. So if I turn on the output, I get 90 milliamps. And if I reduce the current limit until it starts to try and get under 0.3 volts, it will turn off. So if I set the current limit and I go down, let's look at the current here. It's at 90 milliamps. So if I get the current limit to be under 90 milliamps, it should turn off. So I'm at 0.3 amps, no problem. 0.1 amps, no problem. So that's 100 milliamps. Let's go to the next scale here and take it down a little bit at a time. So here's the 99 milliamps as the current limit. 97, 96, 93, and there you go. It turned off at 91 milliamps, which is what we expect because it's hitting the current limit and it's bringing the voltage under 0.3 volts. So that's something to be aware of when you're testing at these kinds of levels where the voltage may have to drop below 0.3 volts to recognize the current limit.